Good morning, students. Today we are going to see Unit 6, second topic, that is Input Output Management. Myself, Professor Avhad BS, Sri Chhatrapati Shivaji Maharaj College of Engineering, Nepti, Ahmednagar. Let's start. So, last time in Unit 6, we have seen the file management topic. In that, we have completed different points like file management concept, access method, directory structure, protection, file system implementation, directory implementation, allocation method, free space management, and all different points. Now, in this unit, the another topic, that is input output management. In that, we will see what is meant by input output devices, what is meant by this organization of input output function, then input output buffering. So, what is meant by input output devices? Input output devices means what? When user sitting in front of computer system, user using different devices connected to your system like keyboard, mouse, printer, scanner, as like different devices, and these devices performing different tasks related to input passing end user, operating system performing processes on that input and generating output with the help of devices, and this concept is known as input output devices. These input output devices are categorized in three parts. First one, human readable, that consists of printers, video display terminals, keyboards, as like that. Then machine readable, that consists of disk, tape drivers, sensors, and third category, that is known as communication, which consists of digital line drivers and modems. So human readable devices means different printers like video display terminals or keyboards, mouse, as like that, which are devices which are connected to your system, and human get easily to interact with these devices. That is known as human readable input output devices. Machine readable devices means what? That devices which recognize identify by machine, that is known as machine readable. It include disk, tape drivers, sensor, which can be identify sense these devices, known as machine readable. And third one is nothing but your communication, which include digital line drivers, modems, like whatever modems lines which are included. So there are different or difference between these input output devices. First one, data rate. The data transfer rate of the device vary on large scale. Whatever the data transferring from your input device to your operating system, from operating system to your output device, that data transferring rate get varied depending on their large scale or devices. Second point, unit of transfer, stream of bytes or character in large block, that is unit of transfer. Third one, data representation, different data encoded schemes are used for different devices. When you are going to use keyboard, you are going to be typing your alphabets like A B C D E F G A, whatever that. Okay, but computer system get accepted this input with the help of encoding format, so that these are the point related to input output device that encode this data in proper format and accepted in your system for a different device. And fourth one, nature of error, that vary from one device to another. Whatever the structure of your data devices, get varied depending on their nature. Next point is organization of input output function. Device management is the part of operating system responsible for directly manipulating hardware devices. Okay, it is implemented through the interaction of device driver and interrupt routine. So, device management is the part of your operating system. Okay, already we have seen in fourth topic or unit for operating system services like device management, memory management, file management, different functions or different services provided by operating system to end user. Out of that, this is device management, which provide a facility or part of your operating system for a direct communication or manipulating with your hardware. For example, when you are going to connect your pen drive to your system, it will get detected. That is example of your directly manipulating hardware device. Is nothing but device management. It is implemented through the interaction of device driver and interrupt. Means what? When you are going to connect your pen drive to your system, it will get interacted with your device driver and interrupt routine. Now there are different techniques which are used for performing different input output operations. In that, first one is programmed input output. The processor issue an input output command on behalf of process to an input output module. That process then busy wait for the operation to be completed before proceeding. In this point, program input output, when user passing input command to system, that command is get considered as a particular process to your system. That process are going to be gone into cycle of your operating system, that is new ready running waiting terminated, and depending on that life cycle it will get completed. That is concept of program input output. Second technique, interrupt driven input output. The processor issue an input output command on the behalf of process. There are two different possibilities. First one, if the input output instructions from the process is non-blocking, then the processor continues to execute instruction from the process that issued the input output command. And second one, if the input output instruction is blocking, then the next instruction that processor execute is from the operating system, which will put the current process in blocked state and schedule another process. Third technique, that is direct memory access. A DMA module control the exchange of data between main memory and input output module. The processor send a request for transfer of block of data to the DMA module and is interrupted only after the entire block has been transferred. There are different steps related to perform a different input instructions. First one, application process request read operation. Application process means what? For example, when you are going to open your desktop, when you click on notepad, that application is get open in front of user, and that application are going to be read by operating system with the help of instructions provided by user that open notepad. That is concept of application process request read operation. Second step, or to perform input instruction, device driver queries the status register to determine if device is idle. If device is busy, drivers wait for device to become idle. Idle means what? Which device driver are available in your system. When that becomes free, that driver you are accessing and performing your task related to input output. Best example, suppose 10 computers, in all 10 computers are connected through LAN, and between that one printer is available. When particular user giving any print, until completion of that user task, another user's request are going to be in waiting stage. When that task is completed, that printer is available to user. That is concept of related to waiting and idle. Third one, the driver store an input command into controller's command register, thereby starting the devices. Fourth one, when device driver complete its work, it save information regarding the operation that began with device status tables. So this device driver when complete their task related to input output operations, later that it will store that information in your device status table. Next one, by that time device complete operation and interrupt the CPU, thereby causing interrupt handle to run. Sixth one, interrupt handler determine which device code interrupt. It then branches to the device handler for that devices. Next one, device handler retrieves pending input output status info from the device status table. Next one, device handler copies content of controller data register into user process spaces. Next one, device handler finish work and return controller to application process. Next point is related to DMA. A special control unit may be provided to allow transfer block of data directly between an external devices and main memory without continuous intervention by the process. This technique is called DMA. DMA can be used with either polling or interrupt software. DMA is usually used for data transfer from or to disk. Many bytes of information can be transferred in single input. So in this way, DMA is mostly used for data transformation related to your input output. These are the structure how your data are going to be stored, transferred, moved, or read write as like that. This figure consists of data count, data register, address register, then control logic, and over that it will perform different operations like data lines, address line, DMA request, DMA acknowledge, interrupt, input output as like that. DMA data transfer operations. First one, program makes DMA setup request. What are the programs like application programs like Notepad, WordPad, file access, like Excel sheet, as like that are going to be setup request. Program deposit the address value A and data count. Third one, program also indicate the virtual machine address of the data on disk. Here VM stands for virtual machine. Every operating system having their own virtual machine that provide facility to encode your data and run on that particular operating system. DMA controllers record the receipt of relevant information and acknowledges the DMA complete. Device communicates the data to controller buffer. The controller grabs the address bus and data bus to store data one word at a time. Whatever these different address buses or databases are going to be stored in the form of data and at a time one word are going to be stored. Data count is decremented. Last one, the above steps are repeated till the desired data transfer is accomplished. So at the time DMA data transfer complete, signal is sent to the process. Next point is related to your input output buffering. Buffering is a technique by which the device manager can keep slower input output devices busy during time when a process is not required input output operations. These input output buffering are categorized in three different types. First one, single buffering, second one, double buffering, third one, circular buffering. Single buffering. In single buffering, what happens? Firstly, user interact with system like keyboard mouse system. It will perform any task over that system. That task are proceed to operating system. Operating system uses their services and passes instruction to their drivers and devices and completed user task related to input output devices. For a block oriented device single buffer, input transfer are made to system buffer. After transferring, the process moves the block into user space and requests another block. Whenever process moving into user space, these are waiting and later requesting for another block. User space can be processing one block of data while the next block is being ready. Operating system is able to swap the process out. Swapping concept we have seen in file management topic. In that, temporary your data are going to be loaded into that memory block. Later, again swapped in and swapped out for execution. Operating system must keep track of assignment of system buffer to the user processes. Double buffer. There are two buffer in the system. One buffer is for the driver or controller to store the data while waiting for it to be retrieved by the higher level of the hierarchy. And other buffer is used to store data from the slower level module. So this double buffering is also called as buffer swapping. Last one, circular buffer. When more than one buffer used, the collection of buffer is itself referred to as circular buffer. In this, the producer cannot pass the consumer because it would overwrite buffer before they had been consumed. The producer can only fill up the buffer j minus 1 while the data in buffer j is waiting to be consumed. Here j minus 1, some formula are going to be used during this technique. So thank you so much. In this way we have completed unit 6 second topic, that is input output. Let's once again we have seen what today we have com- completed, what we have seen. First of all, we have seen what is meant by these input output devices. Input output devices in these are categorized into human readable, machine readable, communication. Human readable means what we have seen like printer. Machine readable is related to machine disk tape, driver sensor. Communication is related to modem. Later we have seen difference between input output devices like data rate, unit of transfer, data representation, nature of error vary from one device to another. Later we have seen organization of unit input output function like device management is the part of operating system which are responsible for directly manipulating hardware devices. It is implemented through the interaction of device driver and interrupt routing. Later we have seen the techniques which are used for performing input output. In that first one, programmed input output. Second one, interrupt driven input output. Third one, direct memory access. Then we have seen steps to perform input instructions. that application process request read operation. Device driver queries the status register to determine if the device is idle. The driver store an input command into controller's command register, thereby starting the devices. When device driver complete its working, it saves information regarding the operation that is began in device status table. By that time device complete operation and interrupt the CPU, thereby causing interrupt handler to run. Interrupt handler determines which device causes interrupted. It then branches to the devices handler for that devices. Device handler retrieve pending input output status information from the device status table. Device handler copies content of controller data register into user process space. Device handler finishes work and returns control to the application process. Later we have seen concept DMA. A special controller unit may be provided to allow transfer of block of data directly between an external device and main memory without continuous intervention by processor. Means DMA is mostly used for data transfer purpose. The structure we have seen. Then DMA data transfer some operations like program makes DMA setup request. Program deposit the address value A and D. Program also include virtual machine address of the data on disk. DMA controller record the receipt of relevant information and acknowledges the DMA complete. Device communicate the data to controller buffer. The controller grabs the address bus and data bus to store the data one word at a time. Data count is decremented and the above steps are repeated until your data transfer is accomplished. Later we have seen input output buffering. That is, it is a technique by which device manager can keep slower input output device busy during time when process is not running input output operation. These input output buffering are categorized in three types: single buffering, double buffering, circular buffering. In single buffering we have seen this structure like input output transfers, transferring user space request another block, user process can be proceed, OS is able to swap process out and some task performed. Later we have seen double buffer. There are two buffer in the system. First one buffer is for the driver and second one is for store data purpose, and that is also called as buffer swapping. Last one is we have seen that is circular buffer, in which when more than one buffer is used, the collection of buffer is itself referred to as circular buffer. Thank you so much. In this way we have completed unit 6 second topic. Thank you.